In this video, I'll explain how to solve rational equations, part 2. I think in the first video I called it or named it solving algebraic equation with fractions. Same thing, rational means fractions or fractional in math. And so this will be part 2. So I'm going to do some equations that are a bit more complex. So say we have y divided by 8 minus y over 4 equals y over 16. So this is a bunch of fractions, and it's just as if we had y minus 2y equals 16 or something, but we have fractions here. So one way to do this is to find the LCD and just get rid of fractions right away. This is how I was teaching how to do these in the previous video in part 1. So when you're looking at the different denominators, we always know that the LCD is going to be the biggest denominator, 16, or bigger. So 4 does go into 16 evenly, and 8 does go into 16, so 16 will be the LCD. So instead of working to make these be the LCD by multiplying them by number and then doing to the top what we do to the bottom, we usually do that, we're going to do this in a way that we just get rid of fractions right away. And then we can work on the problem. And so what we're going to do is multiply each term by the LCD. The LCD is 16, so I'm going to distribute this to each term in the next step and multiply this by 16. And then in our very next step, we should have no fractions at all. Just get rid of them. It's one way to do it. There's a couple ways to do this problem at least. So when we're looking at 16 times y over 8, take that aside and look at it. 16 is really 16 over 1 times y over 8. And when we multiply fractions, we can multiply straight across, or we can cross cancel first and then multiply straight across. So we know 8 goes into 8 one time, and 8 does go into 16 two times. So that would make 2y over 1, or 2y. So this right here gets replaced by 2y. Then you have the minus sign, we'll have the equal sign here. Now we do 16 times y over 4. We take it over here and write it, 16 over 1, so we can look at it that way, times y over 4. So we can cross cancel, 4 goes into 4 one time, 4 goes into 16 4 times, and you can see what we get. That's 4y over 1, or 4y. So this gets replaced by 4y. And then we look at y over 16 times 16, really 16 over 1. So the 16s cancel, and 1s are left, and that just equals y. Anytime you have something that looks like that, it'll just equal the y. So y goes right here. Now see, this problem is the same thing as our original problem. It's equivalent, it's the same equation. We just made it look better. Now we've got to solve for y. Well, we have like terms on the same side of the equal sign, so we need to simplify or combine those. So 2 of those minus 4 of those is negative 2 of those. Negative 2y equals y. It's very strange looking. Kind of equation. And there's a few ways to solve this, but we're going to do this way. So we're going to add 2y to both sides so that we can combine it with y. If we add 2y, that'll make it disappear from this side, as 0 will be left, and then we can combine those here. I'm going to take this into the next slide. So we have, let me write what we had, negative 2y plus 2y equals y plus 2y. So this will make 0, so I write that. Since there's nothing else left on that side, I'm going to write that and see what that looks like, and this is 3y. Now I want the 3 away from y. It's being multiplied by y, so I do the opposite operation and divide. I'm doing the processes that I know to do. You could just think too, 3 times what gives you 0, and you know the answer. But if you do it this way, the 3's cancel, y is by itself, and you're looking at 0 divided by 3, which is 0. So y equals 0. You can write it like this, is no problem. And so y equals 0. Very strange that an equation will come out that way, but that's what we got. So 0 is a real number, so it's just fine that y equals 0. I'll do another problem like that. Y over 5 minus 14 over 15 equals y over 3. So we're solving for y. We have a bunch of fractions. First thing we do is find the LCD. Determine what that is. I'll go ahead and write this problem again just so I can work on it instead of messing up the original problem. So we have 5, 15, and 3, and 5 and 3 both go into 15, so that's good. The LCD will be 15. The LCD will always be the biggest number of your denominators or bigger. Never will be smaller than 15 for this problem, for example. So what we're going to do with 15, do you remember, is multiply each term by 15. And we're going to get rid of fractions right away. So first we're looking at 15 times y over 5, and I'm going to write what that is right here, and then the minus sign and the equal sign. So 15 over 1 is what we're looking at, and take it aside. I don't ever do this work in the middle here so that I can see my original problem, see what I did, see how the equation changes all the way each step down to the answer. So I take this little work over to the side. So 15 over 1 times y over 5, and so the 5 goes into 5 one time, 5 goes into 15 3 times, and so 3y over 1, 3y, same thing, and that whole thing is replaced by 3y. Now we're going to look at 15 times 14 over 15. If you already know the answer, you can just write it in, but I'm going to explain it for everyone. So the 15s can cross cancel. We really have 1s left, so that answer is just 14. And so 14 goes right here. And then we have y over 3 times 15, or 15 over 1. And so 3 goes into 3 one time, 3 goes into 15 5 times. So it looks like 5y, or 5y over 1. And so we're going to put 5y right here. See, we have no fractions. Much easier to solve than this craziness. I would rather do it this way than work to make this denominator be 15 and this denominator be 15 and show how it changes and everything. But maybe you like that method, that's okay. So now we want the y's to be on the same side of the equal sign so that we can combine them. So I'm going to move the 3y over to this side. And so I'm going to do that by subtracting 3y, because that part makes 0, and that'll leave negative 14 by itself. I have to subtract 3y on this side as well. So what we have is negative 14 equals 2y. And you can think in your head, 2 times what equals negative 14? And we know that's negative 7. You can do that. Or go ahead and divide both sides by 2. So that's how to do that problem. I'm going to try and show you some different arrangements of equations with fractions in them, but it's the same thing. So negative half equals negative 4/3 w plus 3/5. So we have a number, a w term, and a number. So again, we find the LCD. We don't want to deal with this mess of fractions, so we're just going to find the LCD and get the heck rid of fractions right away. I'm just going to write my problem again so that you can see what the original problem was. So the LCD is going to be 5 or bigger than 5. We have 2, 3, and 5. We need a number that each number can be divided into. So we kind of look at 5 and think of multiples of 5. So 2 and 3, they don't go into 5. So how about 10, when 5 times 2 is the next one? 2 goes into 10, but 3 doesn't go into 10 evenly. So then how about 15? 5 times 3 is 15. Well, 3 goes into 15, but 2 doesn't. And then what about 20? 15, 5, 10, 15, 20. 2 goes into 20, but 3 doesn't go into 20. You just keep going until you find the LCD. And one way to find an LCD is you could always multiply all of these denominators, 2 times 3 times 5. And that might not be the lowest, but that'll get you where you want to go. So that probably happens to be the LCD anyway. 2 times 3 is 6, 6 times 5 is 30, so we'll say the LCD is 30. So what do we do with 30? Do you remember? We're going to multiply every term by 30. Okay? So the very next line, this will be a negative number, I can see that, equal sign. Then the very next line is going to have no fractions. So 30 times negative half, that's basically cutting 30 into half. You can check with your calculator or take it aside and look at it. That's negative 15. Then we're doing 30 times negative 4/3. So I'm going to write that here. I know this is going to be a W term, so I'm going to stick that in. So negative 4/3 times 30, which is really 30 over 1. And we cross cancel what we can. So 3 goes into 3 one time, 3 goes into 30 10 times. So it looks like 40. Negative 4 times 10, so negative 40. Make sure that you carry your signs. So I do have the negative already there. Negative 40W. Now we look at 30 times 3 over 5. So 3 over 5 times 30, or 30 over 1. And we cross cancel if we can. 5 goes into 5 one time, 5 goes into 36 times. So it looks like 18 over 1, or 18. So 18 goes right here. So see this equation? Much better than dealing with this craziness. So we're trying to solve for W. This is a number and this is a number, and they need to be on the same side of the equal sign so that I can combine them. So I'm going to make 18 disappear on the right side and appear on the left side. I'm just writing down the equation so that you can see what I do. So what I'm going to do is subtract 18 from both sides, because that makes 0, and that's how it'll disappear from the right side. And I've got to subtract 18 from that side as well, the left side. So negative 15 minus 18, that's like you spent $15 and you spent 18 more dollars, so you're really in debt $33. And then we just have negative 40W over here. And so I think I'll write this right here, this work. This is like my side work right there. So negative 33 equals negative 40W. We want the negative 40 to be away from from W. So it's being multiplied by W. So I do the opposite operation and divide by exactly what I want out of there. And I have to do that to both sides. So this side will be positive because negative times negative equals a positive. I think that doesn't reduce. And then W is right here because these two cancel. And so that's it. That's crazy. W can equal 33 over 40. I mean, just get rid of fractions right away. I'll do another one. We have 1/3 V minus 7/5 equals negative 2/3. So guess what we do first? I'm going to write the problem again so I can work on it. Maybe I won't do that in the next step just because I'm trying to get you into good habits. We find the LCD, that's the first thing. We have denominators of 3, 5, and 3. So our LCD is not going to be smaller than 5. It's going to be 5 or bigger than 5. So 3 doesn't go into 5, so we need to find a multiple of 5. 10, 3 doesn't go into 10, but 15, those 3's go into 15. So we'll use 15. And what we do with the LCD is that we're going to multiply each term by the LCD. And we'll get rid of fractions in the very next step. So 15 times 1/3. Now first of all, I know this is going to be a v term. I'm going to write whatever that comes out to be here. The subtraction sign, equal sign, this is going to be a negative number. So those just carry down. So we're looking at, is 15 over 1 times 1/3. And you can see that as 15 divided by 3. Or you can cross cancel, which is kind of extra work. That's going to be 5 over 1, or 5. So 5 goes right here. That's a 5v term. And then we're looking at 15 times 7 over 5. So 15 over 1 times 7 over 5. And we can cross cancel. So 5 goes into 5 one time, 5 goes into 15 3 times. And so that looks like 3 times 7, which is 21. So 21 goes right here. And then we have 15, or 2/3, and I already considered the negative right here. So 2/3 times 15 over 1. We can cross cancel there. So 3 goes into 3 one time, 3 goes into 15 5 times. So that looks like 10 over 1, or 10. And it's always the same thing now. With equations and fractions, it looks crazy, but you got it. Just find the LCD and get the heck rid of fractions, and all you have is a nice equation here. So we want v by itself. That means we want the 5 to go away and the negative 21 to go away. We start with the number kind of farther away first and make that appear on the right side. Oops. And so what I'm going to do, since that's subtracting 21, I'm going to add 21. Whatever is needed. I have to do it to this side as well. Whatever is needed, so that leaves the 5v by itself. So 5v plus 0, or 5v, equals 11. Negative 10 plus 21. And so when you have 5v over 11, we want the v by itself, so we want 5 to go away. So we're going to divide by 5, since it's being multiplied by 5. Those cancel, and that makes v equals 11/5. I've got about 4 more problems so that you can see the variations that you might come across, and you'll see it's pretty much the same thing, same process. So next we have negative 7y plus 5 over 2 equals negative 2/3 y minus 7 over 2. That is some crazy equation with fractions. But so what? They can bring it on, because all we'll do is find the LCD and get rid of fractions right away. So you can see the original problem. I'm going to go ahead and write on this line just to shortcut, give my hand a break. So you look at the denominators. We have a 2, a 3, and a 2. And so the LCD is going to be 3 or bigger than 3. So 2 doesn't go into 3, but 6 sounds good. So the LCD will be 6. So what we're going to do is multiply every term by 6. Both terms on this side and both terms on this side by 6. And we're going to write that in the next line. So 6 times negative 7y is negative 42y. 6 times 5/2. We can take this over here and look at 6 this way, times 5/2. And then you can see 2 goes into 2 one time, 2 goes into 6 3 times. That looks like 15. So positive 15 goes right here, then the equal sign, and whatever we get next is going to be negative and a y term, and then the subtraction sign. So 6 times 2/3, and you can make that 12, you can multiply them straight across, 12 over 3, and see that as 4, or you can cross cancel and see that as 4. So that'll be negative 4y right there. And now we have 6 times 7 over 2. You just write that down and see what it looks like. And then that looks like 21. So 21 goes here. So now we have negative 42y plus 15 equals negative 4y minus 21. So we need the y's to be together on the same side of the equal sign so we can combine them, and we need the numbers to be together on the same side of the equal sign so we can combine them. So I'm going to do this one at a time. You could choose any 4 things here to start with. There's 4 different ways to start, and if you do your algebra correct, you'll get the same answer, the correct answer. I'm going to choose to move 4y, negative 4y, over to this side. So I can just do it this way. And so I'm going to add 4y to both sides. You can write that in wherever, but I wouldn't write it in under. Don't ever do that under, because it looks like division. So negative 4y plus 4y makes these kind of cancel out, go away, is 0. So what we would have on the left side is negative 42y plus 4y is a negative 38y, and then plus the 15 equals negative 21. Now I need to move the 15 over to this side so it can combine with its like term. So negative 38y plus 15 equals negative 21. And so what I can do is subtract 15 to make that disappear from the left and appear on the right side. But I'm going to go ahead and combine it with the negative 21. So over here we have negative 38y equals negative 36. And I'll take this to the next slide. This is a bunch of side work here. So what we have is negative 38y equals negative 36. And so negative 38 is being multiplied by y. I need that negative 38 away from y, so I divide by negative 38 and do that to both sides. So these cancel, and y is by itself. And negative divided by negative is a positive. So I've got to reduce 36 over 38. I know that they're both divisible by 2, so let me see. This will be 18. This will be 19. And that's it. Next problem. Negative 7 over 2 x plus 2 over 3 equals negative 3 over 2x minus 4. So we look at the denominators and determine the LCD. We have 2 and 3 and 2. So it's going to be 6 again. So we're going to multiply every term by 6. So first, this is going to be a negative x term plus sign. I like to write these in sometimes. Some number is going to go here equals a negative type of x term and a subtraction sign. So we have 6 times 7 over 2, so I'm going to take this over here. And that means 2 goes into 2 one time, 2 goes into 6 3 times, that's 21. So negative 21x, 6 times 2/3 is next, so 3 goes into 3 one time, 3 goes into 6 2 times, and that's 4. So plus 4 equals negative something, Then we have 6 over 1 times 3 over 2. And so 2 goes into 2 1 time, 2 goes into 6 3 times, and that's 9. So negative 9x. And then we have 6 times negative 4, which is a negative 24. So here's our equation. So I need the x's on one side of the equal sign on the same side so that I can combine them. And I need the 4 and the 24 on the same side of the equal sign so I can combine them. So I guess there's 4 different things you could do is all correct. So what I'll choose is to move the negative 9x over to this side. So negative 21x plus 4, and then negative 9x, and I'll move the negative 24 over this way. So what I'm going to do is add 9x, and I have to do it to this side as well, because that will make 0. 0 minus 24 leaves that minus 24 by itself. And then over here, we have negative 21x plus 9x, so that's negative 12x plus 4. Now we're aiming to solve for x, so we need the negative 12 away from x, and we need the 4 away from x. We start with a number kind of farther away from x first. So we have negative 12x plus 4 equals negative 24. And the way I'm going to get the 4 to move from the left side and appear on the right side is by subtracting 4 from both sides. So this way I'll have negative 12x left on that side equals negative 28. And so we want the negative 12 away from x. So I'm going to take this over here. Maybe I'll have more room. Negative 12x equals negative 28. I need the negative 12 away from x. Negative 12 is being multiplied by x, so we do the opposite operation and divide. Divide by exactly what you want away from x, and you have to do it to both sides. So these will cancel, and x equals, now negative times negative is a positive, so we have to think, does 12 go into 28 evenly? I don't think so, but that can reduce. So 28 divided by 4 is 7, and 12 divided by 4 is 3, so that'll be it. X equals 7/3, to write this correctly here. Okay? Now here's one more type of problem. It looks a little different, but I've got 2 examples of this, and that'll be it. So 6w plus 9, all divided by 5, equals 7w minus 6 over 6 plus 3. Look at this craziness. You just have more on the top. So what we do is we find the LCD of the denominators there. We have 5 and 6. So it'll be 6, or it'll be bigger than 6. So 5 doesn't go into 6, 5 doesn't go into 12. You got 18 is probably 30. So 30 is the LCD, and we're going to do the same thing we've been doing. Multiply every term by that LCD. So this is multiplied by 30, and these are multiplied by 30. Okay? And I'll show you how to do that now that we have a little more going on here. So here's the equal sign. So 30 times all this stuff. We're going to take this aside. 30 is really 30 over 1 times 6w plus 9 over 5. So we cross cancel. 5 goes into 5 one time, 5 goes into 36 times. So what that means is we have 6 times, I'm going to squish this in, 6w plus 9. So we can just write that right here. As long as there's no fractions, that's just fine. 6 times 6w plus 9 goes here instead of that fraction. And then 30 times this stuff. So 30 over 1 times 7w minus 6 over 6. So 6 goes into 6 one time, 6 goes in 35 times. So what that makes is 5 times 7w minus 6. So that goes right here. And we'll deal with that distributive property in a minute. And then plus 30 times 3, which is 90. So I'm going to separate that. Next, what we need to do is use the distributive property to multiply the 6 by those two terms and the 5 by these two terms. Because we want to combine like terms and get w by itself in the end. So this will be 36w plus 54 equals 35w minus 30 plus 90. So we look for like terms on the same side of the equal sign. These are unlike, they're not alike. Over here we can combine the 30 and the 90. So we'll have 36w plus 54 equals 35w plus 60. So we want w terms to be on the same side so we can combine them, and we want the numbers to be on the same side. So what I'm going to do is make 35w. You could move the 54 over here. You can do two things at once actually. Whatever you want to decide to start with is fine. I'm just going to choose to move the 35w from the right side over to the left side. And I'll do that by subtracting 35w from both sides. Just squish it in here. Come on, internet. So 30 minus 35w. So on the left side, I'll have 36w minus 35w. That's 1w, which we really just write like this. And plus 54 equals, now 35w's cancel on this side, so we have 60. Now we need to subtract 54 from both sides. So that I can combine it with the 60. And I want to take that work right over here. So I have w equals, because this goes away, w plus 0 really is just w, and then 60 minus 54 is 6. So w equals 6 after all that. Now I'll do one more problem like that to help emphasize the process. So say we have 27 equals 9y plus 3 all over 7 plus 4y plus 9 over 3. See how that looks? We have fractions, let's get rid of them right away. So we have to find the LCD. So the LCD will be 21. And what we're going to do is multiply every term on both sides by 21. And so I don't know what 21 times 27 is off the top of my head. I have to look at a calculator or do it by hand. So I get 567. That'll be fun to deal with. So 567 equals, now 21 times all of this term. I'm going to take this over here. It's really 21 over 1 times 9y plus 3 over 7. So 7 goes into 7 one time, 7 goes into 21 3 times. So that makes 3 times 9y plus 3. And I'll write that right here, 3 times 9y plus 3. And then plus 21 times all of this. So that'll make 21 over 1 times 4y plus 9 over 3. So 3 goes into 3 one time, 3 goes into 21 7 times. So we'll have 7 times 4y plus 9. And so that will go right here, 7 times 4y plus 9. And I'll cut this out. And so we need to use the distributive property. So we have 567 equals 3 times 9y is 27y, and 3 times 3 is 9, and then 7 times 4y is 28y, and 7 times 9 is 63. So we look for like terms on the same side of the equal sign. So we'll have 567 alone on that side, but we can combine these two and these two. So 27 plus 28 is 56, so we'll have 56y. And then 9 plus 63 is 72. Now I have this number and this number that I need to combine, so I'm going to end up subtracting 72 from both sides. So I'm working to get that y by itself. So minus 72 here, minus 72. So 567 minus 72 is 495. And this adds up to 0, so that's how 56y gets left by itself. So the way we can do this is to divide both sides by 56. And I would use your calculator. I mean, if you want to do it by hand, go ahead. Where these cancel and leave y by itself, you can start to really see how things are going to work and do this more quickly. But see if 56 goes into 495 evenly. Nope. So then we can try and reduce this fraction, 495 over 56. I mean, 56, is that divisible by anything good? It's divisible by 2. Well, 495 is not divisible by 2. You can play around with your calculator to see. I'm not finding anything at all. So I guess the answer is this crazy amount, this crazy fraction with these numbers here. But you see that was a crazy problem. But you see the process is the same. So, replay parts of the video repetitively, whatever will help. But hopefully that'll help you.